Hey guys, I'm Mr. Bahoric, and today we are doing multiplying with exponents. I'm so excited to be doing this lesson. I've been on vacation, and I haven't really been doing that much math. Well, I have, but I've just been kind of slacking off on making the videos, and I'm just excited to get started. I'm in a good mood, I'm rested, I'm relaxed, I got a nice beard going, so alright, so let's do this, multiplying with exponents. Now in class I did a little bit of a review to start off with, but here I'm just going to jump right on in. So let's say we're doing something like 6 to the 4th times 6 squared. Well, instead of doing 6 to the 4th and figuring out what that is, and 6 squared, 36, and multiplying big numbers like that, there's a shortcut. Okay, and let's write this out the long way so we can kind of see this. 6 to the 4th. Well, that's just 6 times 6 times 6 times 6. 4 sixes, right? And then we have times 6 squared. 6 times 6. Well, all of this, well, how many 6s are there? Well, there's 6 of them, and they're all being multiplied. So that's just 6 to the 6th. Interesting, huh? So let's use a variable. Let's say we have e to the 5th and e to the 1st. Okay. Well, that's writing it out long ways. E times e times e times e times e, so that's e to the 5th, 5 e's, times one more e. So in total, there are 6 e's, e to the 6th. So if you notice what's going on here is, what we're doing is we're just adding up the exponents. So in this one, it was e to the 5 plus 1. If you're multiplying powers with the same base, e, you just add up the exponents, e to the 6th. It goes true for the one we did before. Okay, we're just adding up the exponents because they have the same base. Now remember, this is only when you're multiplying powers, and it's only if, whoa, I don't know what just happened there. It's only if they have the same base. Okay, only if they have the same base. So in this example, e was the base. In this example, 6 is the base. It only works if they have the same base. So for example, I can't do this. I can't say, okay, 5 to the 3rd times 4 to the 4th, and I can't say that's like 5, 4 to the 7th. That just doesn't work. Okay? I can't do that. I can't add those exponents up because they don't have the same base. 5 and 4 are not the same. Alright, so let's actually do some examples. Okay, let's do some real examples because this seems like it's really not that bad of a concept. It seems okay. But when you start seeing some of the examples, it's kind of like, oh my gosh. So let's erase some of this. Back down to a manageable brush size. Here we go. Alright, so let's start off with example 1 here. We're going to do a to the 5th times a times b squared. So what we're looking for here is we want to notice that the only two that have the same base are the a's here. B does not have the same base as a, so we can't combine any exponents here. So what we have here is a to the 5th times a. Remember, that's also could be written as a to the 1st, but we normally don't write the 1. So 5 plus 1, we add the exponents up, and that's a to the 6th. And the b squared, it just kind of goes along for the ride. So b squared. It doesn't have any like common bases to combine with, so it just stays like that. Alright, number 2. Okay, we're going to do a lot of examples because examples are the best way to learn how to do this. So let's say we have a negative 2 x squared times 3x to the 5th. So all of this is being multiplied, and we've got some coefficients this time, so things look a little bit different. So I'm going to do this the long way. Okay, I'll show you the shortcut in a second. It's really not that bad. It's not really even a shortcut, if you want to call it that. But the long way is, if I wrote it this way, negative 2 times x squared times 3 times x to the 5th. I didn't really change anything. I just kind of spaced it out a little bit more. So remember, it's multiplying. And in multiplying, the order doesn't matter. So I can kind of switch things around. So let's say I did, I'm going to just reverse the order of some things. Negative 2 times 3 times x squared times x to the 5th. Okay, it didn't change anything, it just changed up the order. And I think you might be able to see what you're going to do now. Okay, well, we could do negative 2 times 3, that's negative 6. And we can do x squared times x to the fifth. They have the same base, so you just add the exponents. So x to the 7th. And there's our final answer. Now, there's a shortcut way of doing it, and I wouldn't even really consider it a shortcut. But basically the way I look at it is say, okay, where are the coefficients? Okay, they're being multiplied, so multiply up the coefficients first. Negative 2 times 3 is negative 6. And then I just look at each variable. Okay, so x squared, x to the 5th. It's being multiplied, so I can add up the exponents. And that's x to the 7th. So it's not even really a shortcut. I just kind of like talked out what I did long ways here. So that's how that works. Let's do the number 3 here. Make it a little bit trickier this time. Let's say I've got, in parentheses, 4x squared y squared times 3x to the 4th times x to the 6th y to the 4th. There is a lot going on in this problem. So first things first is I want to look at the coefficients and multiply those up first. So I see a 4 and a 3, that's 12. And now I'm going to go through each variable and just count up how much I have. So x squared being multiplied by x to the 4th. Okay, so I can multiply that up. That's x to the 6th. And then plus 6 more x's, that's x to the 12th. I've got y squared and y to the 4th. Add up the y's, that's y to the 6th. Hopefully my video doesn't get too noisy. There's kids going between classes right now. But that's my final answer right there. All right, let's do one last example with this concept, and then I want to move on to something else real fast so I don't make the video too long. Okay, but let's go ahead and do, let's do a squared parentheses 3ab minus a cubed b. Now careful, we have a minus in here. All right, so the first thing I want you to notice is that we have a squared times 3ab. So I could rearrange this. Okay, so it says 3 times a squared times a times b, which is the same thing. Well, I can combine those a's. That's a to the 3rd. So now I have 3a to the 3rd b minus a to the 3rd b. So we're not done yet. Be careful, these are like terms. 3 of something minus 1 of something else. Or it's the same thing, excuse me. So 3a cubed b minus 1a cubed b. So that's 2a cubed b, because they're like terms. Same variables, same powers. Sweet. So now I want to move on to something else. And I saved this for the end. There goes the bell. I saved this for the end because you have to know the rule that we just learned in order to do this. So now let's do something called multiplying a power by a power. So I'll write that out. Powers, not times powers, raised to a power. So powers raised to a power. So ooh, that sounds crazy, but I'll give you an example. So like before we did 2 to the 3rd times 2 to the 5th, and we got 2 to the 8th. But now, what if I do 2 to the 3rd raised to the 5th? So it's a power being raised to another power. So let's write this out long ways. Okay, long ways, it's like saying 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times, 2 to the 3rd times 2 to the 3rd. Okay, sound like a broken record, like if you actually know what that is. I know MP3 generation / streaming music generation might not know what a record is, but I was kind of skipping a lot. Anyways, so 2 to the 3rd, 2 to the 3rd, 2 to the 3rd, 2 to the 3rd, 2 to the 3rd. We can add all of these exponents up because it's just multiplying powers with the same base. So that's 2 to the 15th. Maybe you noticed something there. Let's do another one real quick. Okay, what if I said e to the 6th raised to the 3rd? Well, that would be e to the 6th times e to the 6th times e to the 6th. Again, 6 plus 6 plus 6, that's 18. So e to the 18th. So you may have noticed something there. What we're doing here is we're actually just multiplying the powers. 3 times 5, that's 15. 6 times 3, that's 18. So the shortcut here is when you're raising a power to a power, you multiply the exponents. Okay, so let's do an example real quick. Let's, we'll go back to this color. Okay, let's say I have 2a to the 3rd squared. Now, long ways, I can say that's 2a to the third times 2a to the third. And then it's just like the problems we were doing before. 2 times 2 is 4. And a to the third times a to the third, you add up the exponents, a to the sixth. But if I want to use my new shortcut, okay, my new raising a power to a power rule, okay, I want to do it this way. I want to say, okay, well, distribute this exponent to each one of them. So it's 2 to the first, but now it's 1 times 2, because you multiply the exponents. 2 to the first, 1 times 2. And that's 2 squared, or 4. And then a to the third squared, multiply the exponents, that's a to the sixth. So you get the same thing. So let's do another one real quick. And this will be the last example. So let's say we have 3 squared a to the sixth, b to the third, c. And all of that's being raised to the 7th. Whoa, I know, right? So I don't want to do this the long way. I'm going to distribute that 7 so that it goes to each one of the exponents in here. Oh my gosh, I cannot believe that just happened. There we go. Alright, so each one of the exponents is going to go in here. And even that c, it has an exponent, there's a 1 there. So let's do this. 3 squared raised to the 7th. Remember, you multiply the exponents, so that's 3 to the 14th. A to the 6th times 7. So 6 times 7, that's 42. So a to the 42. B to the third, multiply the exponents, b to the 21st. And c to the first, 1 times 7 is 7. So c to the 7th. So that would be my final answer. And I could go ahead and do 3 to the 14th power if I wanted to. It's going to be an enormous number. So it's actually about 4,782,969, but I'm not going to write that out. So anyway, I'm Mr. Pork, and this has been Multiplying with Exponents.